Alright, so let's talk about some milling concepts here. So we just did some drilling and some hand jogging to create features in the previous module. So for this module, we need to worry about actually, cutting. So there's a few things that are going to change. Instead of the rapid code and can cycles, we're going to have to focus on cutting linear and circular. Okay, so the linear code is G01. And the difference between G01 and G00, as G01 requires a feed rate in IPM for the most part. Okay, so inches per minute. So this is for cutting at a feed rate. Okay, so it's a linear move, linear cut. Okay, so that's the first one we're going to need. The second one we're going to need is going to be a G02 and a G03. And these are circular moves. This is clockwise, and this is counterclockwise. Okay? And they also require a feed rate. Okay? Or an F command. Now, these are all modal. Okay? And it is critical that you understand that, because one of the issues that most people come up with is you go from a linear move to a circular move. You got to put a linear move back to cut again. So I have a couple examples we'll be doing, mill part 3, mill part 4, that will take care of that, and hopefully understanding of that. Okay. Now G01 is pretty simple. What I'll do is I'll erase this quickly, and G01 is going to have a X and Y typically for us, but it could also have a Z. Okay, so a lot of commands, is going to be, let's say we bring, this is our end mill, and this is the front view of the workpiece. Okay, you're going to come in just like I showed you before, 2 inches, G43 with an H value, 2 inches. And that'll be a rapid, so you'll have some sort of G00 up there, and it's modal. You will probably rapid or feed to like 100 thou above the workpiece. I will rapid usually. I like that little break. It's a good idea to check your tool comps that way. But whenever I'm going Z negative, I try to use a G01. Typically it's slower. Okay. G01, again, like I said, requires a feed rate. So if we go G01, Z minus 0.030 or whatever it is, okay, at a feed of 10 inches per minute, all right, that'll always be 10 inches per minute. It's not based on 5%, 10%, whatever the rapid you're running. Okay, so it's a good idea to always Z minus, whenever you're going below the workpiece down this way, to use a G01, okay? So that takes care of the Z, and again, we'll go through an example. But the rest of this, all right, is working with X and Y moves. So once the Z is at a certain depth, typically you could be ramping in, helicaling in. I'm not worried about that for now. But if we have to, let's say, cut out a square, okay, all these would be linear moves. Let's say, this is 0, 0. That's your work offset, let's say. Okay. We have an end mill, and the end mill equals 0.25 diameter. Okay. Or let's say, just to keep this simple, ½ an inch. And the part here is, let's say, 1.0 by 1.0. To cut around this workpiece, okay, typically we're going to program using the center of the cutter. So we're going to command this to go G1 X 0.0. That's ideal, but the problem is that the part's going to be undersized because the cutter action happens out here. Okay? So if you do not, if you want to compensate for this, you need to add or subtract half of the end mill radius to cut around something, and that becomes tricky. Now a square or a circle is one thing, Okay, but if you have an angled line, like let's say it looks like this, you can run into issues because you have to compensate here to here. All right, so it requires a little bit of trig, and if you look in the machinist handbook, it has stuff for that. Now, that is unlikely. I'm going to go over cutter compensation right now, just while we're talking about linear interpolation, G01. Then we'll talk about G02 when cutter comp's already on. I think that'll be by far easier. So let me erase this, and I'm going to talk just quickly about cutter comp, and then as we apply it, it'll really help. So like I said before, you could compensate numerically, okay, for the cutter radius, and that's not a problem. It just becomes more math, and it's sort of a waste, and you don't have a lot of tools at your disposal, and I find it to be, in a lot of ways, a waste of time. So we're going to cover cutter comp. So cutter comp. Now, we have already used cutter compensation in using G43 Z positive. What these are is going to be G41 and G42 for left and right. Okay, and these two codes also require a D value, and that is very similar to the H value, and as in you need to actually tell the machine what that D value is. So in the G41 code, you'll have a D number, G1, 2, 3, 4, 5, whatever it might be, and that is just a value in the tool offsets on the controller, and that value can compensate the cutter. The nice thing is here also is if the cutter is cutting big or cutting small, you can compensate very quickly. All right, you can also change this comp number, right, and change for end mill sizes doing it this way. So this is very powerful and really helpful. All right, I recommend that you use this, and I'm going to make sure you do, because to do it any other way, it just is not. I mean, it's possible, but this is pretty standard now. So let's talk about some other variables with cutter comp. Okay, the one big thing here, all right, is that you must lead in. Okay. In our case, at least the radius of the cutter, or at least the amount you're trying to compensate. Okay? So if we have our square, and this is 0, 0 work offset. Okay? And this again, it's 1 by 1. The distance we need to lead into the part must be equal to or greater than the radius of the cutter. And the reason for that is that you need to lead in and lead out with a move. Okay, so you must lead in and lead out. Okay, now typically for parts like this, if I can, I will lead in and lead out the diameter of the intended tool. Why is that? Because it gives you room either way. Okay, if you have to change an end mill size, you have some room. Okay, you've got plenty of lead in. The problem is that if the cutter, here's the deal, if this is, okay, the radius of the cutter, okay, or actually it's going to look more like this, sorry. That's more like the diameter. If that's the radius of the cutter's going to look something like this. That's the minimum to actually function. Okay? What I like to do is give myself some room. So I'll end up having the cutter plunge right around here, feed in, and this is lead in. Okay? And on this line would be my comp. Okay? So let's work through this simple program. This is not one of the example parts, but let's just work through this. Okay? If I have this workpiece, and, forget about the top of the program, you want to have your end mill plunge in, let's say, an inch away. So let's say the end mill, and this is a 1/2 inch end mill. We're going to go to X, Y, X minus 1.0, Y 0.5, right in the middle of the workpiece, just for this example. Okay, and that'll be a G00. Then we're going to end up plunging, so G, and we don't need another G00, so bear with me, it is modal. Come on. And what we'll do is we will just G43, Z 2.0, H1, assuming that it's T1 we're using. And then we'll go G1, Z minus 0.1, all right, at a feed of 25 inches per minute. Some number, all right? We're plunging in air, so it's sort of irrelevant. If you're plunging into the part, you got to make sure this is accurate. Now, we're down below. Now we need to turn our comp on, so we need to lead in. Okay, we're an inch away, the half-inch cutter, we got plenty of room. Okay, and again, in our case, it is going to be at least the cutter diameter, and it's technically at least the radius, but we'll go with cutter diameter or more. If you're only compensating for, 5 or 10 thousandths, and you are actually numerically offsetting the code, like I showed you in that first example, where you can actually compensate the actual G code for the end mill radius, you do not have to lead in as much. The lead in has to do with the amount you're trying to compensate, which in our case is 1/4 of an inch. That's the radial compensation. Okay, you do type in ½ inch in the controller, but we're compensating 1/4 of an inch, which means we need to at least lead in 1/4 of an inch. I try to do at least a diameter, because when it happens is if you edit that 1/4 of an inch, for comping it to size, you run into issues. All right. Also, if you change cutter sizes randomly, then you got to reprogram. That's the other issue with compensating numerically in the program, by changing the actual coding, because then you got to reprogram. Now, if you're using Mastercam, you can repost very easily. So I almost always, you'll see if you are taking the Mastercam course, there are different ways to compensate. They follow through. This would be the control method in Mastercam. It's also on my YouTube channel, so you can check that out. So Mastercam cutting cutter comp types, something like that is the video title. This would be the control method. The where method would be if you are using comp G41 or 42 and numerically offsetting the cutter in the code. But we're going to use the control method. So then this line now, assuming we're 1 inch away, -1, is going to be G41. And why is it 41? Because we want to climb mill. We want this cutter is going in this direction. We want to go this way. Okay? So we want to comp it to the left. If we wanted to go this direction, we would comp to the right. It's where is the chain geometry, or where is the cutting geometry going to be if you were driving this like you're driving a car. Okay, to your right or to your left. If you're going to take a left here, go this way, the cutter geometry, or not the cutter geometry, the part geometry will be on your right. We need to comp to the left. Okay, the opposite over here. The cutter geometry is going to be to our left. We want to comp to the right. So we're going to comp to the left, going to X0 point using the D1 offset. Okay, now the cutter, okay, and I'll clean this up quickly. The cutter is going to move, and I'll get rid of these 1 inch numbers. Remember that. The cutter is going to move to right here. And it's going to comp whatever value is in the D1 column. And then remember, the D1 column is on diameter, so it automatically knows to only compensate for the radius. So now we're right here. Okay? But we have to move this way because we're comping to the left. It looks ahead. If we put a G42 here, it would be over here. Okay? So we want to comp to the left. So the cutter comp is on. We would then program right around this workpiece, okay? In our case, we would go to Y 1.0, X 1.0, all right? So that gets us over here. We would go to Y 0 point, down here. X, not in the same line, because that'll cut an angle. I'm running out of room here, so we'll go over here just for example. And again, I'll go over this with discriminator. So it's a little clearer. Okay, so we'll go to Y0, then we'll go to X0, then we'll go to Y.5, and that gets us back to here. So we went around the workpiece pretty simply using just our specs around here. Now, we need to turn the cutter comp off. You need to lead out. Very important. G40 x minus 1.0. Very important to have this line. Comp off. Now, let's say we need to do another depth of cut. This is where I would go, you know, z minus, like another 100,000, so z minus 0.2. And then I would copy and paste G41 and go around again. And I don't like leaving the comp G41 or 42 on. All right, go in Z minus and then turn it back on again, or just leave it on the whole time is what I'm trying to say. I like to turn it off, lead in, lead out, Z minus, lead in, lead out, Z minus, lead in, lead out, because it just works better. Okay, you will have far less issues. Okay, it's also much easier for me to diagnose. Now, one thing to realize also is we are feeding at 25 inches per minute. You could change the feed rate here to, let's say, F10.10 inches per minute, whatever. We'll talk about that when we get into the actual example. Okay, so that is a basic linear example of not only using G1 to cut around something, but also using cutter compensation. Okay, so I'm going to take a break here, and then we'll come back. We'll talk about circular interpolation with cutter comp, and then we'll get into programming our example. All right, so let's work through circular interpolation. Okay, so let's say we have to cut around a circle right here, and the circle diameter is 2 inches. Okay, let's say our 0, 0 is in the middle. Okay, and we want to work around the workpiece counterclockwise. Okay, something like that. All right, so let's program this. Now, this is a 2-inch diameter circle. I'm going to program in quadrants just to show this. Okay, so let's turn the comp on. We need to plunge over here, and we need to move to right here. Okay, let's say we are using the 1/2-inch diameter end mill. Okay, if we look at our code for this, I'm not going to go with the plunging, the Z minus. I'm just going to focus on, we're already there. We're going to go G42, okay, X 1.0. It's 1 inches from here. We're going to comp to the right. The lead-in amount, our previous X and Y, wherever this is going to be, okay, would be X 2.0. So the lead-in amount is 1 inch in this case. Plenty of room. Okay? So we're right here. That would be a G1. Okay? Now, I prefer to have a G1 code modal before you turn comp on. I do not like to put the G1 on the same line. Okay? So you could just put a G1 before it with no move. You could put a G1... Usually you're going to have the G1 on the Z move before you're here with some sort of feed rate. You can put a feed rate, if this is D1 and F of 10, you could do that. It's up to you. Okay, but let's just focus on getting the comp on. Okay, now we got to start turning. Okay, so we need to go counterclockwise. So we're going to use a G03 for the movement. And then with these lines of code, we need where we're going, X and Y. So where we're going here, all right, then we're also going to need some information on the swing point. Okay, so let me actually redraw this a little bit more compressed here. So we're going to go G3, X, Y. We're also going to need an I and a J. Now, you can use an R function, but we're going to focus on I's and J's for these examples. Okay? So we're going to program this in quadrants. Okay? So the X and Y position, where this position is right there, it's going to be X 0 point, Y 1.0. Comp is on. So the cutter right now is going to end up moving like right here. It has no swing data, but we want to go right here with the cutter. Okay? We need information on the I and the J. There's also an available K value. That would be for the Z if we were using it. The I, J, and K values all define the swing point of an arc. Okay? The I is the X, J is the Y, K is the Z. These are incremental from where you are to the swing point. Okay? So let's define that right now. Okay, I'll change into a different color. We are essentially programming right here. We'll ignore the comp. The comp is already taken care of. What is the swing point from here to here? Okay? We're going to use an I because it's with the x-axis, and it should be the radius of this arc, which is 1 inch. But here's the key and why this is incremental, is this is a negative 1 inch, because from where we are to the swing point is negative 1.0. So the I is negative 1, and the J is 0. I do like to put the J even though it's 0. Okay? So now we're here. Alright? We're still moving G3 to get to this position. I'll change colors again. So we got to go here. Alright? So X, Y, I, and J. Okay? The X is minus 1.0 here. The Y, okay, is 0.0. There is no X change to define the swing point, so the I is 0. And the J in this case would be minus 1.0 from where we are to here incrementally. Okay, so now we're here. Let's change colors again. We got to go here. Okay. Again, technically it's there because the comp is on. Alright. So we're going to go X, Y, I, J. Okay. The X, okay, is 0.0. The Y is minus 1.0. Alright. Now the I is coming from where we were. So from here to define the swing point. Okay, and technically it's here. Sorry about that. Okay, the comp is already on. The I is 1.0. The J is 0.0 because there's no change in the Y. That gets us to here. Okay? From here to here, we'll change colors again. We'll just go back to black. To define this point again, okay, we have X, Y, I, and J. We have an X of 1.0, a Y of 0.0, an I of 0.0, and a J of 1.0, because from here to define this point, there is no change in X, all positive Y. Okay? That gets us back to here. We cut the arc. Now, in theory, we should overlap a little bit, but I'm not going to focus on that for this one, okay? Because otherwise you could get a little bit of a spud here. Don't worry about that. Let's try to keep this simple. Now we'll go G40, X 2.0. All right? We just cut that arc. Okay? Now, we could use R values, but I wanted to use I and J's. I want to get this hammered down because I and J's always work. R's can be interpreted differently. You'll see on our one example, it should be mil part 4. The I's and J's are the ideal way to program it because we're going to have issues where we need to define a circle and actually from here, which means that we need to have a J and an I defined. Okay, to define the swing point. Okay? So that's circular interpolation. Again, G3 is on. Okay, notice that we are using a linear command to lead on. If I remember correctly, most machines, I know the Haas's do not let you lead in or turn comp on a circular move. That is why a lot of people will actually will lead in use a teardrop. It is ideal to lead in on an arc. So if this is a wall, you want to lead in like this, okay? Or something along those lines. It doesn't have to be such a steep radius. You just don't want to have it look like what we're doing, which is a line like that. That's not ideal. We'll do that because the code is easier. But a lot of people will lead in using what's called a teardrop. So this is their start point. They'll have to turn their lead in on out here. Then they'll arc. here when the comp is on this move here. Okay, so that's also an option, just to bring that up. So what we can do now is I'm going to go, we'll have a transition here for the video so you can pause. I am going to open up the workbook and show you the page references for this and talk about it a little more. And then we'll get into discriminator, and we're going to focus on basic mill 3 for the first one. And we have a couple issues with that one we got to address. We have to rough it out a little bit prior to the actual finish pass. So we'll address that, and then we'll take a look at the next example, which should be mill part 4. So there'll be a pause here. So pause here and open up the Haas mill workbook, mill programming workbook. All right, so now back into the mill workbook. I am on page 30 with G00, which we already covered. Then it gets into G01, which we talked about, linear cutting. Make sure you read about that. Also, this one just has a with cutter comp on, just a simple cutter comp line. Then we get into G2 and G3 and talks about the IJKs and the arcs and sort of what's going on here. It gets into, if you got different planes active, what's happening, arc position, arc start position, rotation direction, etc. The I's and J's, what they mean in the workbook. R, it talks about how it's easier to define, but it's also easier to screw up at the same time. So I do prefer the IJK method. I feel like that once you get that, it's really not a big deal. So I think it's just easier. I also like to program in quadrants if I am doing a full 360. You don't need to do that, but I think a lot more machines, especially if they're older, will take that and not throw an error. On some of the machines I used to run, it was hard to do a full arc with one line of code. I know the newer ones can do it. It goes over that, but I still think quadrants are easier. And I recommend you follow that, knowing that if you go to industry, you won't have an issue, depending on whatever machine, no matter what machine you're going to be running. Then it gets into each G2, clockwise. Then there's I and J for G2. Then it gets into G3. So make sure you read all this. It goes through the I's and J's just like we did. Goes through R a little bit. Again, read about R, kind of understand it's there, but I really want you, and I'm going to grade you on your mastery of using the I and J and K method. I think it'll serve you better as you transition into the workforce. So here's another example. I recommend you work through this if you want the answers or you want me to check it. You can see me in lab or shoot me an email. Okay? Again, the start finish points. We're going to work through that. These, if I take a look here, they are not turning, they're not using cutter compensation. Okay, so you do have to comp for the end mill, but if you want to throw this in discriminator and just use it with cutter comp, that's ideal. I want you to use cutter comp. I don't think you're going to gain much by not using it. Time is critical here, so I think it's important just to use cutter compensation. After that, so those pages, and I'll give you those page numbers now. It looks like it's page 30, if I remember right. Let's just confirm this. Yeah, page 30 starts with G00. All the way down through to page 41 is circular interpolation in the workbook. Read that, understand it. You do the extra exercises if you're confused. And then as we get down here, we get into our tool comps. There's 43. Let's see here. We'll find cutter compensation. All right, cutter comp. Cutter compensation in the X and Y plane starts on page 60. So you got G40, G41, 42. Okay, and what they're all about, what the D number is all about. Okay, and then it gets into programming with it. It gets into, again, programming without cutter compensation. Some of these angle examples, what are they? You got to calculate the points. Yes, you can do it, but it just adds a level of complexity that I think is just unnecessary. Okay, with cutter compensation, very simple. All right, it goes over the lead in, lead outs. Again, here's more, examples sort of like what I drew, where you have to trig out these two triangles here that are blacked out to find those points without cutter comp. And again, it's possible. It's really not that big of a deal, but it just adds a level of complexity that, again, I just don't think is necessary. So pay attention to that and work through it if you want. With cutter comp, very simple. Gets into the lead in, lead outs, what's critical, what's not, working with cutter compensation. Okay. you have different options here. So they have an example here. If the cutter is a 1/2 inch diameter, you want to leave 10th stock for a finish pass, you can work with the cutter compensation numbers and call up different comps to achieve that. So if you look at this example, they're calling up comp with diameter 21, okay? And diameter 21 is using 520 as a diameter, okay, 10th side. D1 is using 1/2 inch. So you can run the same program twice, okay? One to rough it out, leaving some for finishing, and use the compensations that way as a value to just make your program bigger or smaller for either leaving material to copy and paste, or to, you know, comp the part in as you go. So it's a very powerful option, and we really need to start using it as soon as possible. So make sure you read this. There's an exercise, work with it, very important. There's all the advantages, okay? There are restrictions, okay? There are options. If you're on different planes, you got to use G141, 142. Don't worry about that. Okay, a cutter compensation command must be used in the same block with an X or Y linear command. Very important, okay? You want to make sure you lead in and lead out, okay? When activating cutter comp, you must, all right, select a clearance point that controls your lead in. Bring the Z axis down without cutter comp on, so Z is not a factor with G41 or 42, so only turn 41 or 42 on when the Z is already established, okay? Deactivating, again, so make sure that you do not turn the comp off when you are still cutting the workpiece. Make sure that you comp on and comp off. Okay, you can read the rest of this. All right, again, select a clearance point that is at least half the cutter diameter off the part. Again, use the actual. Okay, that's a good practice. Okay, in theory, you can, depending on what you're trying to compensate. If you're trying to compensate for the radius of the cutter, theoretically, you can use the radius of the cutter. No movement will occur, but it should kick on. That is really pushing it, because if you have to compensate, you got no room. You want to go at least a diameter off the part or more. But if you know, again, that is, it doesn't have to be the diameter of the cutter if you're compensating only, let's say, 5 thou or 10 thou. So there's a lot of variables here that you need to take into account. When hand programming, when we are compensating for the full radius of the cutter, at least lead in the diameter of the cutter. Okay? So at least half the cutter diameter off the part. That's the radius. I recommend the diameter off the part. Gives you room to tweak things. Let's say you break the last 1/2 inch end mill in the shop and you got to go to 9/16 or you got to go to 7/16. It's very simple to change. Okay? There's different cutter comp exercises I recommend you work through. If you have questions on them, let me know. But it gives you a lot of Haas specific information on cutter compensation. And just to reiterate this, on this cutter compensation starts on page 60 in the workbook and ends on page 69. Okay? So read through that, work through the examples. If you have questions, shoot me an email. Again, these advantages are nice. Some restrictions are good. Make sure, you know, when activating, when deactivating, pay attention to these two. Okay, very important. And that's about it for the workbook. So what I want you to, I'm going to pause here. There'll be a transition. I'll load up Discriminator and also have the PDF for mill part 3 ready. And then we'll start working through that on Discriminator. All right, so let's start working through this part. Let's get our speed and feed information and cutting tool information in. We are going to end up using a 0.375 mil. Okay, and the reason for that is it gives us the program. If we use a 1/2 inch end mill, the program will look like this. Okay, if we use a 375 end mill or an end mill with a smaller radius, the program will actually follow and look like a radius. And you want that, otherwise you get chatter when you have those stop points, okay? So we're going to use a 3/8 cutter. It's going to have 4 flutes. All right, and we're going to use a chip load of 2/1000 and a surface footage of 400. And those are very conservative, but I don't want to waste tools or run this faster at this rate at this point. We're also going to max out at a 0.1 depth of cut, and our width of cut we're going to shoot for no more than the radius of this cutter, or 0.1875. Okay, and that'll be max. Okay, as far as our AE, so or our radial width of cut here. So we'll focus on those parameters. This will, we'll just copy and paste and repeat. This we'll try to keep as much as possible. We'll work with it there. Now, I want you to work through this and calculate these. Make sure you're able to do that, but just to give you the answer, we're going to be working with 4,000 RPM and a inches per minute feed rate of 32 IPM. Okay, now it comes out to like 4,050, but we'll just kick it here. So that's what we're going to be working with. All right. So besides our speeds and feeds, we need to rough this out because a 3/8 end mill is not big enough. It's going to end up looking something like this. It's not big enough to rough this out if we were just going to follow the profile. Okay, so we need to rough it out, and we'll use comp for this. I think it'll help. So let's get some data up on the screen here. We need to find out. Let's work with just this pocket here. All right, to rough it out, and then we'll sort of copy and paste and invert numbers to get it the rest of the way. So I want to start out in space, and this is going to be, let's say, x minus 2.0, right out here. But I want to stay away from this wall, quite a bit. Let's say a 1/16. So half of 1.25 should be 5/8. So 1.25 divided by 2 is 5/8, or 0.625. Let's say a 1/16 away from there, so minus 0.0625. We get 0.5625, or 9/16 of an inch. So 0.5625 is going to be our number. So it's going to be y minus 0.5625. Okay? So we'll use that for some of our start and end points. All right? Now, the next line, we want to come in here and we want to cut with the radius of the cutter with a max, okay, AE, or radial depth of cut, of 0.1875 max. Okay, could we get away with more? Oh yeah, but let's just work with it this way. All right, so let's take a look from the center of the part, which is going to be our work offset. Sorry, I hope I was clear on that. We are going to work 0, 0, because that's where all the numbers come from. So this is work offset. Okay, we're working with the center, and actually what I'll do is I'll just change color here to something green. Okay, green equals G54. All right, so we need to come in to take a 3/16 depth of cut. So here to here is going to be 1/8 of an inch. Okay, so it's going to be 3 inches minus 2.75 divided by 2 should be 1/8 of an inch. So we need to take that into account. So if we have 2.75, okay, divided by 2, and that's going to be 1 3/8. So this position here is 1.375, right? So 1.375, knowing that it's 1/8 of an inch from here to here, okay, again, we'll do the math. 3, or 1.5, should be half of this, minus 1.375 is 1/8 of an inch. All right, so minus, okay, from 1.375 is 1/16th, okay, should be 1.5 or 3.125. So 1.375 minus 0.0625 equals 1 5/16. That's our first X move. Okay, but here's the deal. We need to turn comp on. Okay, because right now if we program here to here, that point, we're actually taking more. And that would be okay, but we want to know where the edge of the cutter is at all times. So we want to program, okay, to the center of the cutter. All right, because it's easier mathematically. That way we always worry about where the cutter center is. All right, and that way we will be creating and worried about this 3/16. Okay, now this 5625 number, okay, is the wall we want to create. We want to stay a 1/16 away. Okay, so we don't want to necessarily, go here. We're going to create this with the lead-ins, with the cutter comp. We want the actual, if we zoom in on this, if this is the wall, we want the cutter to be here, and we want this to be there, 0.0625. Okay, so we need to take into account the radius of the cutter. So we are going to focus using comp on the outside of the cutter. Okay, but we're going to program like we're here, which is much easier in the math. Okay, so let's take a look at what this is going to look like. All right, so we have some numbers to work with. Let's start our program right here. All right, we'll go in, turn the comp on to here, come in, cut, turn the comp off. Okay, and then we can focus on other numbers as we go in. Okay, so I'm going to pan over to discriminator, and we'll take a look at the programming of this. Okay, so I have this already set up where I'm going to x minus 2.0 and y0, which is going to be our plunge point out in space. Surface spindle's on, coolant's on. We got our feed rate in. We're just going to leave it up here as modal, so it'll stay on that with any cutting moves. We're 100 thou below, calling up H1. And now we're ready to get into our cutting toolpaths. So we want to stay on the left-hand side of this operation. So we're going to go G41, Y minus 0.5625, D1. Okay, and we got to make sure that we have the 3/8 in the D column on the offset page in the Haas controller, because that'll be critical. For right now, that is fine. And you'll see the solid line coming down. Okay. Now we can go X to minus 1.3125. Okay. And that will create the X minus 3125. Okay. Because it's compensating to the left the D1 value. And that's the whole point. I'm getting this across right, is that we are programming to the center of the cutter, almost like you would like a pencil point, which is easier to calculate. But that's not really what happens on the CNC. You have to take into account the radius of the cutter, which will create the actual wall of your workpiece. So letting cutter comp do it makes the math much easier. So right now it's compensating down to minus y.5625, but it's actually going to create that wall. If we needed to create it without comp, we would have to add 1875. Okay, so we can program to where we're going without having to worry about the cutter radius. Okay, so right now this went over to 1.3125. Okay, so the center of the cutter is right around here. All right, so that should be taking a 3/16 step in the part. Okay, so now we need to go up to y.5625. We need to go to X minus 2.0. Then we need to go G40, Y 0 point. All right, that's our first cut. Let's save there. All right. Now what we can do is we can copy and paste this, and the only thing we're going to have to change is our X value. Let's go to the next one. So we can go right to here, copy, and paste. Okay, and it's going to look identical. Here's the next thing we need to do. We need to go back to our drawing, and I'm going to erase some of this. Okay, we can lose this for now. We know where we're at. We can lose some of this, and I'll rewrite it. We just took a cut of here, right around here. So now what we can do is we can take the next cut. So we can take another 3/16 of an inch. Okay, so if we went to X minus 1.3125, okay, and we're working from center, okay, here. This next line, if we take away a 3/16 depth of cut, so 1.3125 minus 0.1875 equals inch and an eighth. 1.125. That's kind of convenient because that is actually right around here, which is the center of these fillets, or where the center point of the fillets are. So we could do the math on that too. If we know that from here to here, okay, it's 2.75 minus 2.75 divided by 2, 1.375 from here to here, minus half an inch gets us to here, 875. Then if we add the radius, we get 1.125. Okay? So we know, and the reason I did that, we know that if we cut right to here, and this is our end mill, that we will not touch or gouge the radius. Okay? At a 0.5625 step. Okay? You need to be careful of that. Okay, you know you won't. This is not to scale. Okay, so unless you drew it to scale, you don't know. But we know that because the edge of the cutter will not go past this line, okay, and a 1/16 away here, we know we're good because the arc has not started yet. Okay, so let's plug that inch and an eighth in. So we'll go on back over to discriminator, and we will update x minus 1.125. And you'll see a new step occurred. Okay? So we're good there. So let's save. Okay? So now let's take care of that. We are a 1/4 inch away. So we could take that in one shot. We did rough enough out. That's fine. The cutter's 3/8 would be taken over a 3/16 width of cut, which is sort of an issue. Okay? It would probably be fine. But let's take a look and see if we can take a little more material. The problem is, okay, is that we need to avoid these radii. Okay, so you got to be a little careful here. So we're a 1/16 away here. I don't really want to do the math to find out where we can be with the arc. Okay, I just want to get the bulk of the material out of the way. So we could probably take and go, instead of a 1/16 away from the wall, we can go an 1/8 inch away from the wall, because that is half of this radius. Okay, here. So a 1/16 would be like right around here, 1/8 inches here. And then if we are 3/16 away here, that should work out. Okay, so let's get a couple values here. We'll go, instead of this, because right to this wall is 5/8, we'll go a y minus value of half an inch. Okay, so if we go back to our program, we've been going to 5/625. We can copy and paste again, and instead of 5/625, we'll go to half an inch, and we'll go to half inch here. Okay. Now, that takes care of the y. The x is an issue. So the x, we need to take into account the 0.875, which is to this wall, plus, okay, 0.1875 is inch and a 1/16. That'll leave, no more than 3/16 on this wall. Okay, which is fine, all right? Because we're going to end up changing our comps and getting rid of that mostly anyway. So just trying to keep the numbers as simple as I can, I'm going to go to an x, 1 and a 1/16. Okay, and you'll see that step kind of comes in. Okay? And what we'll need to watch out for is when we actually program around this, that these arcs, which do represent the edge of the cutter, the cutter would be right here, don't hit. They should not. So it's a good time to save. Okay? And that takes care of our initial roughings of all 4 of these pockets, essentially. Because what we're going to do is we're going to just invert them over. So I'll show you the first one, and then you could do the remaining 2. I'll catch up quickly just to make this video as short as possible. We'll need to invert some x and y's. Okay, so let's take care of, we'll move clockwise. Okay? Looking at discriminator, G40 is done, this pocket's done, okay? You have a couple options. What I'm going to do is I'm going to go around the workpiece twice, okay? We could do the depth here, change the depth, that's up to you. But I'm going to go around once, and then we'll change the depth, and what will happen is I'll have you change the depth. I'm going to try to keep this video shorter, like I said. So we're at y0. We're going to go to z 0.1. Okay. Now we need to go to a new start point. And we have some options here. You can copy paste this whole thing and we can invert some numbers. That's not a problem. We can go back into here and we'll go right here. Okay. We'll go copy and paste. And here's the deal. So this is where we left off. You could label that first pocket if you want. It's up to you. We're plunging again. Okay. And we need to take into account our new start position. Okay. We did end at x minus 2.0, y 0 point, so we should already be there. But it won't be a bad idea to change here and go to g00. And then go to x 2.0, y. Okay, and here's the deal. We're going to x, my mistake, x 0 point, y 2.0. So we're going up in space, so we got to kind of move around a little bit. Okay, right around there. So then we plunge down in z. Now we need to take care of some changes in our numbers. Okay, so we're going to end up going to x minus. Okay. Then we're going to go to y minus. Then we'll go to x positive. Then we'll go to y positive. Okay. And then we'll go here. Now, I'm going to lose these for now. And just for editing purposes, I'm just going to put a M2. Okay, and all that stuff should not be there. The other thing you do is block, delete it, or put in parentheses. I'm not really worried about it. You could even delete it, just like that. It's up to you. We can copy and paste that later, or we can even copy and paste these and change different numbers. So let's see where we're at. Still not completely right. Okay, so let's go back in, and this is where we're starting. Okay, right around here. So going down, x0, y 2.0, that's correct. Z minus. So we're going to feed and go to x minus, and then we have a y minus. Well, that's not right. We need to go to a y positive. So that should look a lot better. Okay, there's that, and we got this one. So x 0.5625. Then we need to go to y 2.0. Then we have a g40 to y0. That needs to be x 0. So now our pocket looks a lot better. Okay, we're up in space. That is our first initial cut. What I'll do is I will end up just going like this and put in upper pocket. Okay, just for reference. And now what I can do is I can copy and paste from here. Okay, the one thing is we are going to end up here anyway. So if we did this right, if we copy and paste the lines not including our initial position, this should look right. It should not be any change. Excellent. The only thing we need to change is the y to y, our next step, which should be inch and an eighth, y 1.125. You'll see the cut. We'll paste again, and this is going to go to, we got to make a couple changes here. Okay, so we can't really paste that again. Why? Because we changed to y.5. So let's delete that next step. Okay, should be right around here. And also, we really don't need our z minus again. So we can get rid of that too. That's not going to change us here. Okay, I don't think I copy and pasted up here. We have our z.1. We don't have it again. So that was a mistake on my part. So we are good here, we are good here, we're good here. Everything looks okay for our first two cuts. Okay, now we need to get up back into our last cut, right around here. And that looks good right there. Okay, there's our 0.5 numbers. Now this is going to just copy, again, the other pass. But it gives us, and again, you don't have to do it this way. You could literally type it. But it gives us other variables. So if this ends up at x0, okay, that's good. So this is going to be at x minus 0.5, y positive, x 0.5. Okay, and this is going to be y 2.0. Okay, we're going to x0 and z.1. So there is that pass up there. So I'm just changing the coordinates around, giving where it is, on this workpiece. Okay, so these look the same. We should be good. I am going to save. I'm going to pause the video here. What I want you to do is do the rest of the pockets. I'm going to do the same thing, and then we'll come back and do our first roughing pass that goes all the way around this workpiece, which is sort of like that final cut on the G71 in the lathe. That gets us ready for an even cut for finishing. Okay, so all the pockets are done. Make sure that you are climb cutting the entire time, so when you go through like the bottom pocket here, I am working around this way so that the cutter will be cutting clockwise. And now what we need to do is take care of the next operation, which is going to be the next depth of cut. These are all minus 0.1. So down the bottom here, I'm just going to put in parentheses Z minus 0.2 depth of cut. If I can get that in there, of cut. And then I want to go up to the top here and carefully mark. We're going to put this there. So we'll type this in. So we're going to essentially start our program right around here. And we are just going to put parentheses. This will be first left pocket. Stay organized. Okay. So now we have all our pockets labeled. We're going to go here and we're going to go G00 is in modal. So we'll go X minus 2.0. Y 0. Okay, and then we can go up and we can essentially copy and paste everything above that right up to there. Copy and paste. And then what we can do is we can take care of this. So this left pocket on top will go Z minus 0.1 depth of cut, and it'll look very similar. Now we need to go and find our Z minus 0.2 depth of cut and change these depths to 0.2. So there's one. Okay, Z minus 0.2. We'll go down to the next one, Z minus 0.2. Down to the next one, Z minus 0.2. And we'll go down to the last one, Z minus 0.2. And that should be it. So I will save. I'm going to go back to my drawing quickly and double check. We have a, I'll erase a lot of this now. We have a 0.2 depth of cut right here. Okay, so get back in our program, and everything looks good. If we hold down and rotate this up, you see we have 2 depth of cuts. Everything looks okay. All right, I'm gonna get back into here and go to top view. So now our roughing is done. Okay, and now we can go back in and do our our last rough cut. I don't want to say our roughing is done, but our bulk of the roughing is done. So now we actually do a profile pass, okay? So we do need to go back. I'm going to go in parentheses, and I'm going to put rough full profile, okay? And I'm going to go back to X minus 2.0, Y 0. And then what I'm going to do is take care of our G1, Z minus 0.2 feed 32. And now we can start programming the complete profile. Okay, so we're going to do a little circular interpolation here. Okay, so we're right around here. We need to come in to this location, which, if we divide our 2.75 divided by 2, should be 1 3/8. This number should be 875, but I always double check. So 1.375 minus a half an inch, 875. So we need to go to X 0.875. Okay, we'll start right in the middle just to keep it simple. We could start right in the corner, it'd be easier to deburr, but I'm not worried about it for now. So get back into here. So we will go G41, X 0.875, D1. And essentially we might actually end up going to D21. Something like that. Something similar to the Haas manual. Because what we'll do is we'll leave material to finish. So this will be rough full profile. So that's not a bad thing to do. Okay? So then we'll go in, and now we need to program this full profile. Okay? And actually it's going to be X minus 0.875 point, G41, X minus, right there, right here, and there's our cut. Okay, we'll go back to top view. Here we are. So now our comp's on. So now we need to start taking into account the radii. Okay? And the radii are right here. We need these start my endpoints. Okay? So what we need to do is we need to go to y, okay? If this is 5/8, so 1.25 minus, or divided by 2, sorry, is 625. We need to minus 0.25 from that, and that's 3/8. Okay, so we're going to go to y 0.375. Okay, so we back into our program, and we go to y 0.375. You'll see it start. Now we need to change our direction, because right now, again, we're in G1. So we need to go to counterclockwise. So we look at our drawing. Okay, the drawing is going counterclockwise. We need to go to a G3. All right, and now we need our endpoints. Okay, so we need to go to an x and y. The y is going to be 5/8. The x is going to be 875 plus 0.25, or inch and an eighth. Remember, we had the inch and an eighth from what our roughing pass was. So we need to get back into here. We need to go to x minus 1.125 and y 0.625. That's our endpoint. Now we need an I value or a j value. So the I value for this example, okay, it's going to be minus 0.25. So I minus 0.25, j 0 points, there's no change in the y. And you will see the arc appear. And you can hold on the arc and it'll show you the center point of it, etc. Okay, it also gives you the radius, 1/4 inch radius. Okay, so that arc is done. Now we need to go back to G1, and we're going to x minus 1.375. Okay, double check our numbers here. I will make sure that we're good. And that's going to be in this one. And again, 2.75 divided by 2 is the outside of the workpiece, 1.375. Okay, so we're right here, compensated. So we need to go now up to this position. Okay, right here. Okay, so 1.375, since it's a square, it's kind of nice. So we're going to be going to a y position. Okay, we took care of the x, we're right here. We need to go to a y, all right, 1.375 minus 0.25, or y 1.125. Okay, back in here, y, okay, 1.125. And it comes up. Okay, you'll see it building. Now we need to go clockwise, okay, G2. All right, we'll take a look back at our drawing. We need to go to an x, if this is 1.375 minus 0.25 equals 1.125. So x minus 1.125. Okay, and y 1.375. Now we have an I value of 0.25. Take a look. Right there, 1/4 inch radii. All filled 1/4 inch. I positive, j is 0. And you'll see the radius is there. Okay. So let's continue. I'll get right back to the next one and start the arc, and then you should be able to finish it up by then. So again, I'll let you do it, because it's a project you're going to be making. I don't want you to just copy and paste my code. So we'll get back into here, and we need a G1, okay, and we're going to x minus 0.625, right to there, okay. Then we're going to a y, and we can start looking at our numbers again. Okay, if we want this position, it's right there, y 0.375. This one here, these are all going to be very similar, except we're going to be inverting the x and y. Okay, so if we're here, okay, x 0.625. All right, we need to be going to, okay, this number here. Right there. Okay, so that's going to be 875 plus 0.25 inch and an eighth, right to here. Okay, so we'll go in and we'll go to y 1.125. There it is. Here we are here. Now we have a G3 counterclockwise. We're going to x should be 0.375. We'll double check. It's going to be 0.625 minus 0.25. Yes, x minus 0.375. Y 0.875. And when we look at this arc, the way we want to swing it, it's going to be an I quarter of an inch, nothing in the J. Okay, so it's going to be an I 0.25 J 0 point. And you'll see the arc. Okay, we can go to the next one. G1 X 0.375. Okay, and then we do our next arc and work our way around. So what I want you to do is totally finish the profile of this shape. I will do the same thing. We'll come back, and then we'll literally copy and paste it, change our D value to the finish pass, and then we should be ready to save it and put it into the simulator, take a look at it, and see if there's any issues. So go ahead and finish this roughing pass using diameter offset 21, which is right here, and then we will come back and I'll show you how to copy and paste and do our finish pass. Okay, so there's the final part completed. Take a look, everything looks pretty decent. The only thing I want to show you at the end here is that I went past center, coming back a 1/16 of an inch, then turn the comp off G40X minus 2.0. Very important that we overlap. It'll avoid any spud. I think that's going to be important to use, especially for the finishing. So right now it's not super important, but we're just going to copy and paste for finishing and change the D value. So we'll put it in there now. And you must lead off. Very important. You lead in the same way you lead off when you're starting to learn this. You'll see that if that's the edge of our cutter, we're actually in really good shape. You'll see that these steps are about the same. We could probably even edit these to come in a little bit closer, but I'm really not worried about it for right now. Okay, that's up to you. You can see if that's the edge of our cutter with comp on, we could really crank it in. So you see this graph is really helpful. We could probably go in, again, if you want to look at this, if we just look at our first value on the left pocket, and we change our X value on the final pass to inch, we could probably, I think it's like, we can go probably 0.937. We could really push it and get a lot of that material out of there. That's totally up to you. We'll see, you see how it cuts. But again, that should be leaving 3/16, our max, max step. So that shouldn't be a huge issue. Again, we're only taking 100,000 steps to cut, so take that into account. But again, you can see how handy this graph is. We move around, and you see for the most part everything looks pretty good. Again, the simulator is going to be the ultimate, or not simulator, but the machine's going to be the ultimate test on the controller, see what errors come up. But everything looks all right. So again, you could modify that step in. That's up to you. Okay, but for right now, just to keep this short as possible, we need to do our final pass. Okay, so we'll copy and paste all of this right up to here. We're already at the Z depth, so we're going to leave it. So we'll copy and paste. And in between there, I left a space. This will be finish pass. It's the same cutter, so we'll just go D1. Okay. And it's not going to be any different because there's no cutter confirmation in discriminator. So we're done there. So now we can go to G00 Z or Z2.0. Okay. You can then go M5, M09 or M9 is fine. We could then go G53. We can go to Z 0 point. Then we can go. We can turn the machine off now. We can go G53. We could bring it. We have to know what machine we're on to bring it to. And actually, in the Haas's case, it'd just be G53. Y 0 point should work for us. And then we can go M30 and % sign. Okay, so that should work for us. Again, don't be afraid to bring those in if you're worried about that last pass. But you can see why I stayed away. We could cut in closer here, and you could really dial it in with the graph. But without the graph, as you saw earlier, you don't know without really doing a lot of math on paper to figure it out. So this software is super helpful. Okay, so that's it for now. Again, you're going to have to put the drilling cycles in. So spot drill and drill, you have to make this part, but I'm not going to go over that in this lecture. You could add those in with tool changes. So for right now, I'm going to save. I'm going to pause the video. I'm going to load this in the simulator. I won't show you that, so I'll load it. I'll show you where to put in the offsets and what the offsets are going to look like. We'll graph it, see what kind of errors come up, and go from there. Alright, so I loaded the program in the controller here. So one thing I want to point out is in the offsets, notice that I have a diameter value of 3/8 for D1. And if I scroll down, I have a 395 diameter in tool 21. The purpose of that is we're calling up D21. We want to say 10 thou a side away. So that's 10 thou bigger on diameter. Okay, so or 20 thou. So it'll give us 10 thou a side. Okay? The other thing when it comes to the diameter offsets and where they work together, so if you're trying to comp a part in, let's say you got a part and you want to comp it in, it's either got to make it 5 thou smaller, you put a -5 in where. You don't modify the geometry, okay? So let's graph this thing and see what it looks like. All right, we're way out in space, so we'll hit F2 and we'll cursor in. Get this thing somewhat in this frame here. Alright, hit enter and hit cycle start, and there it is. You can see the 2 lines there. If you look closely, there's 2 lines. That's the 2 different D offsets. So it graphs are right, no errors. Let's actually run this. I know it might take a minute, but we'll go into program, and if we run this, okay, we'll see what happens. We're going to be paying attention here. I will go into positions and change that to program for you now, so it makes more sense. All right. So we're going to watch it go through and take a look and do all it. So you'll see the speeds and feeds are good. It's, you know, going to Z minus 0.1, coming around and roughing all these pockets out. Comp turns on and off using D1. You'll see the comp turn on, comp turn off. All right. So that was the first pocket. Okay, now it's going to the upper pocket. See the numbers change. All right, looks good. All right. Looks like we're getting towards the bottom pocket now. We just finished the right-hand side pocket. Last pass on the right-hand side pocket. All right, and then we got to go through our next depth of cuts. All right, so hopefully we will see a movement to x minus 2. We'll go up in the Z. We'll go over. We'll go down again to 0.2 and continue cutting. So we'll watch this go again. And it's rinse and repeat here, just doing a different depth of cut, roughing out each of those pockets. Cancel comp, and again, you can watch the machine work through its motions. All right. And again, I think my naming that should be right pocket, not left pocket, but it's okay for now. All right, getting ready for the bottom pocket. Wrap it over. Z minus 0.2. All right, goes Z.1. Wrap its next position, goes down, and we'll see the comp turn on. D21 is on, it's working its way around, so you're going to see some circular interpolation turning on and off. And it is staying away. You'll see some bigger, numbers staying away that don't make sense because it's 10 thou away per side. All right, again, D21 is active, cutter comp left. And we're getting into the cutter comp cancel shortly. A 1/16th away, positive, over. I'm going to turn single block on now. So take a look here. X 0.875. Let's find a good spot for this. Right here. So notice it's going to G1Y 1.375. You'll see that it's going past. Okay, so it went to G1, and it's X minus 1.375. Sorry. So X minus 1.375. So 0.375 plus 0.1875 equals 5625. So the compensation is working on the controller. Notice how they're different. As it goes through, you're going to see all these numbers. Well, until it's ready, when it needs it, you won't need it on that one because it's getting ready for where it is on the corner radius here. But you see the rest of these numbers working with cutter compensation all the way around this workpiece. All right, you'll see a 4375 when there's a 625. Okay, so we're supposed to be going to minus 0.625. That's the edge of the cutter. If we go 0.625 minus 0.1875, you get 4375. So it goes all the way around this workpiece using cutter compensation. It did the same thing before whenever we're using it. So whether we compensate the D1 value of 3/8, which is going to be half of it, the 3/16, or it's going to be compensating the D21 value that's 20 thousandths bigger on diameter, it's the same. Make sure you don't forget your G49s in here. It doesn't really make a difference, but I still think it's a good idea to put them in. Okay, so that's really it on this one. You know, it runs pretty good here on the controller. So let me know if you have any questions. Again, you know, check your comps. I get back in here, I'd always recheck my, you know, check your finish, your work offsets. The work offset for this part is in the middle. I go through, and again, I'd go through and make sure all my Z heights are right. So I'd go through, whenever you go through left pocket, and you go to, you know, if you go to the next pocket here, make sure you go to Z.1, go to the next one, Z.1, go to the next one, Z.1, go to the next one, Z.1, and then you go to the next one, Z.1, go down, Z.1, 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 so that, you know, it's always going up before it ever goes down into the workpiece. Okay? So then we got, but the only time that doesn't apply is when we're going between the roughing full pass and the finish pass. It doesn't matter. Okay? Again, you can always check that out in Discriminator. And again, single block it in the machine. You know, keep your hand on the feed hold and you'll be ready to go. So if you have any questions, shoot me an email on this one, or you can talk to me in class. And I'll see you in the next one.